All right, this is Geometry 2.2, Monitoring Progress, numbers 1 and 2. Now, this whole section is all about inductive versus deductive reasoning. So, these are two types of ways that we draw conclusions. Inductive reasoning is basically looking at lots and lots of examples and noticing what seems to always be true about them, and then drawing a conclusion about something that must be true about the world. So for example, if I throw something up in the air and it comes down, and I throw that same thing up in the air 1,000 times and it always comes back down, I would use inductive reasoning to conclude that if I throw it up in the air again, it'll come back down. Or on the other hand, if every cow I see is white with black spots, I might draw the conclusion that every cow is white with black spots. So as you can see, inductive reasoning can sometimes lead to good conclusions, and it can also sometimes lead to bad conclusions. Deductive reasoning, on the other hand, is a process where we make certain assumptions about the world, and if those assumptions are true, we're able to draw conclusions about other things in the world. We're going to look at inductive reasoning first. Okay, here in this problem, we are asked to draw the next figure in the pattern. So let's see here. We've got a star, 3 stars. Looks like the center is shaded kind of brown. And I've got one unshaded arm of the star and 4 shaded. And the next looks like the next arm here, kind of to the right of the original unshaded arm, is now unshaded. And then the third figure, the next arm to the right of those two, is now unshaded. So following the pattern, just kind of move this over a little bit, I would probably draw something that looks like, here we go, like that, like a star, and I might just shade in, this last leg right here, and all the other 4 are going to be unshaded. Let's see, going back here, number 3, well, we've got, let's see, a single ball, or circle. We've got 3 circles, so our original one with 2 underneath, and then our original one with the 2 underneath, and now 3 underneath that. So I'd probably draw for the next figure in the pattern is, let's see, like there's 1, there's those 2, there's those 3, and then another layer with 4 underneath. That's not the best drawing. So what I'm using here, I'm using inductive reasoning. I'm looking at a pattern, and I'm simply imagining that the pattern will continue that way, and so I'm using that to draw the next figure in the pattern. I know these tend to be like the easiest sorts of inductive reasoning for most students to understand, but more importantly in geometry, the type of patterns that we're looking at are things that are always true about a particular shape. Do you notice something that's always true about right triangles? Or do you notice something that's always true about squares? And then you would use your inductive reasoning to make a conjecture about something that might turn out to be true about all right triangles or all squares. The trick is we have to use deductive reasoning to actually decide if it really is true all the time. All right, let's look at the next one.